Hello, and welcome to the Liquidity Event. We're your hosts, AJ.
And I'm Shane.
And I'm Matt.
Ooh, curveball right there.
Who's
This
that?
is episode...
The hell? Who let this guy in?
This is episode 90, being recorded on Wednesday, April 11th, airing on Friday, April 21st. Hopefully there have been no major world events or financial news happening by the time this episode airs. On this very special recording, we are going to be talking all about AI. We have an AI expert, specialist, jack of all trades, or Matt of all trades, we should call him, here on the show today. Shane and I are going to interview him and ask him a bunch of questions about how this shit actually works. Matt, it's great to have you in the studio. How are you doing today?
I'm doing well. It's exciting to be back on, and I've been loving how much AI has been popping up on your podcast recently. You know, always exciting to hear someone talk about my industry.
What is the dumbest thing that either of us has said about AI that's wrong?
Oh no! Here we go.
You know, I gotta say, I feel like I hear lots of dumb takes on AI, but you guys have been pretty good. I think there's one comment. I think
Oh shit! Here we go.
had mentioned, but this was more about the industry. But I think somebody had made a comment about Copilot being owned by OpenAI, and I think that was the only thing where it's not owned by OpenAI. But beyond that, you guys are doing like exceedingly well.
Oh, I wonder who made that mistake.
I wonder who made that mistake.
I wonder who said that.
That's so weird. Well, we're going to learn a lot today. I know, Matt, you're very passionate about this and have been working in the space for a long time. What's going on your side of the world? You're not in the United States. Is that correct?
I am not in the United States. I'm in Belgrade, Serbia, which, you know, same place I was in the last time, where, you know, every standard machine learning American lives. But yes, I'm over here. You know, I will say that tech here does seem like it's really exploded recently, so that's exciting to see. The quality of developers and just how skilled people are is really nice here. So it's been a great fit. Can't believe I've been here for like a year now.
Wow, amazing. Are you either of you? Are you watching or reading anything interesting at the moment? Past Shane tax season.
I feel like Shane and I will have a more interesting answer than this.
It's April 12th,
so no.
No. Cool. I am feeding IRS prompts into ChatGPT though, which is fun. So
cool. How's it
IRS
doing?
publications, not prompts. Prompts are different. I guess it is a prompt. The publication is the prompt. The prompt is the publication.
Man is the machine. I am watching the third season of Ted Lasso, which is just always like delicious, light, fun, good-hearted comedy. So highly recommend. If anyone is not on the Ted Lasso train, get on it right away, even if you don't like soccer or football. Just a reminder to our dear listeners, we have our podcast survey up for one more week. The deadline is this weekend. There'll be a link on our website page or show notes, brooklynfi.com/episode 90. You can fill out that survey to receive a $10 Amazon gift card. So do that if you have not already. Should we hop into it? Let's talk AI.
Well, I think we might want to reintroduce Matt to the audience, because we want to give some credentials on why we want to understand why we're even asking Matt these questions. Because Matt did develop he was a software developer for one of our proprietary tools, which is not, I would not say like a heavy machine learning tool, but there is machine learning involved in there. But your background was, I don't know, 70, 80% machine learning in the past, Matt. Give us a little bit of a rundown, a little bit of background on your professional development.
Yeah, for sure. So I've been a little bit all over the place, but my undergrad studies were in statistics. You know, I worked as a statistician for a while. Then I studied machine learning, studied mathematics, and most of my career has been, like you were saying, probably 80% has been in the machine learning space. And then a small amount outside of that was in app development. But in the last maybe 4 or 5 years, I've gone quite a bit heavier into the app development and, you know, marrying up these two technologies together, which has been a lot of fun and something I've really enjoyed doing. So when I, met you guys and got to work with what you're doing, it was sort of the perfect project to bring those skills together.
And how old are you, Matt?
I am 33.
All right, there we go.
33 and a third, perhaps?
When somebody says my whole career has been in this topic, you got to ask them how old they are.
That's true. That's true.
Just cut them down to size.
I've been coding for machine learning since maybe like 2012 or so.
Amazing. Okay. So you've seen the arc of machine learning bend towards AI, maybe not. Well, we're going to ask you about AGI. Is that how we pronounce it? Or is that the acronym for
AGI.
general? Yeah.
Yeah.
Artificial general
intelligence. Yeah.
Yeah. Maybe we should wrap up the conversation there because that will be the Skynet version of this conversation.
I like it. I can really go off the walls with the theories of where that's going.
Hell yeah. Let's do it. I'm sorry, AJ. I think I interrupted your initial question. Can you want to hop back into it?
Yeah, I feel like can we just get a definition of like AI? You're right, Matt. Like ChatGPT is in every article. Like that's what we're talking about because that's what a layperson understands. They can go to openai.com and type in a prompt and be amazed by AI. But like, what are we actually talking about when we talk about artificial intelligence in your community?
Yeah, I feel like if you ask 5 people, you'll get 5 different answers. But the way that I think about it is it's a specific field of machine learning where we're trying to mimic the process of how people and how brains learn. So, for hundreds of years, we've been taking, this idea of math and statistics and trying to build models to explain the world to ourselves. And those methods have gotten a lot smarter. They've gotten better over the years since we've done, since we've been improving them. But then, when our computing power got really, really good, well, now instead of solving an equation one time by hand, we can solve, 1,000 different variations of that equation 1,000,000 different times. And that unlocks a lot of, capabilities for us to model the world more accurately. And the majority of everything in machine learning is mapping inputs to outputs, trying to find patterns in there, and then being able to make a prediction about the output, about what goes into the input, right? But we had a breakthrough where some smart people came up with this idea of, all right, well, here's how, here's a rough approximation of how a brain works, right? We have neurons in our brain, and then electrical signals go through them. And as we repeat a pattern or see a pattern over and over again, we develop nodes on those neurons, and then we have an electric path. I'm sure anyone who actually knows how neuroscience works will hate that explanation. But
I think for most people, it's good enough.
Yeah. But that's also, that's also a good analogy here, though, right? Because the way that we do it in machine learning is also a really bad approximation of how the brain does it. But we try to mimic that. And, all of these things, especially this, it's just some creative ways about, combining statistics, combining, linear algebra, combining calculus, and you randomly initialize a bunch of, mappings between your inputs and your outputs. And then over and over and over and over again, you update incrementally what is going on with all those different numbers. And then eventually, after you do that enough time, you're really, really good at mapping those inputs to the outputs. And generally, when someone's talking about, deep learning, they're talking about some version of this neural network approach, backpropagation of randomly assigned weights across the.
Cool.
So that's kind of how I think about it. Someone else might also include, anything where we're smart at being able to predict. Like, there's a lot of really good regression and classification algorithms where, we can say, what is this thing, or predict the number. But generally, that doesn't seem like what people are talking about when they mention AI.
Yeah, because from our perspective, it's, we heard about AI being developed and should we be afraid of it because the robots are going to get too smart and take over. But like from your perspective, like why was ChatGPT so different from everything else that had been developed before it? Why was it so impactful for the rest of the world outside of the machine learning community?
It's a great question. Of course, it is a really impressive model, and it is a technological breakthrough. But we've had plenty of technological breakthroughs in the past in this field that did not get the same level of exposure. But I think the main reason here is how accessible it is to somebody who hasn't studied what's going on here, right? Like, you can go into ChatGPT and you can ask it something that you could not ask Google, and then you get this ability to interact with it. And we're starting to see something that mimics what we attribute to being uniquely human in that. Whereas, we had amazing things in the field before, but like, unless you had studied it for a long time and you knew how to code and you had the right data set to pass through it, it didn't really make sense, or it wouldn't be as like clear how powerful it was.
Yeah, I mean, speaking of Google, it sounds like the way that Google revolutionized search in that it was a easily accessible, beautiful, blank canvas to index the internet. Like, it seems like ChatGPT was sort of a similar approach where maybe there were other technological models that are maybe even better at actually synthesizing information and having a conversation, but literally the design and approach of ChatGPT for a person to be able to chat with it like it looks like an AIM conversation, right? Like,
Yeah,
what's up,
exactly.
ASL? Like, has anyone asked ChatGPT like ASL? What were you gonna say, Shane?
Oh yeah, I wanted to speak on that topic, and one thing I wanted to draw attention to is like, yeah, I am curious about the history and what Matt's talking about, and like I think the appealing thing about ChatGPT is this: it does have this like human layer. Which I've heard is like a security layer. Actually, it serves two functions. One is that like it talks like a human, and it also makes sure that if you ask it a question about the underlying, and when it goes and references the underlying language model, it doesn't bring you bad stuff. There's like a layer that says, actually, we're not going to talk about how to make dynamite, and we're not going to talk about how to administer poisons and all that. And I'm just curious if there's like a parallel to the way when programmers use a language like Python, it gets converted into assembly, right? Because there's layers that go down to the actual machine, the ones and zeros and the frame. And the mainframe. So I didn't know if that was a suitable parallel or like a suitable analogy, Matt, and if there were other language models that are potentially better at getting answers, but you just have to be able to speak Python as opposed to the no code that is GPT, so to speak.
So I don't think that's a perfect analogy, because when you compile code, and I'm impressed that you knew that it gets compiled down to assembly. But yeah, when you compile,
I listen to you when you talk.
I appreciate that. Yeah, like when you're compiling code, there's no element of randomness, right? There's a very strict set of rules of how something works. So if you say, 10 times 5, how do you solve that? There's always a very strict set of processes that you go to get the answer to that problem, right? But with something like these large language models, the reason that they're so hard to do, the reason that any of these types of machine learning things exist, is because there aren't a strict set of exact rules to be followed. There's randomness, there's noise, there's times where the rules aren't going to make sense, right? So you can write the exact, if somebody writes an if statement in Python, this is how you compile it, and this is how you make the CPU of your computer process the data through it. But if you say, how do you learn to speak German, right? There's a million different ways you could answer that in multiple languages. So there's a lot more noise to it.
It's a bit more biological than the other tools that we've developed.
Yeah, that is true. That's
amazing. Speaking of, asking it questions, we've heard about these new jobs that come into the space since it's been released. They're called prompt engineering.
Yeah.
And I don't really know what that means. Can you help me with that? Is that training a biological creature or this biological tool, which I'm going to start calling it from now on, to answer the questions how we want it to, or is it training it to think a certain way? What is prompt engineering? I've heard it pays quite well. I'm curious how that, why it pays so well and how it influences the models.
Yeah, so maybe I'm a bit uninformed here, but when I think of someone who says that they're a prompt engineer, I think of it kind of like somebody who puts like Googling as a skill on their resume.
Well, it's paying $300K a year, so
I am very good at Googling.
So, and yeah, there probably are different levels of the complexity, right? And there, of course, there needs to be a step that translates, whatever prompts goes into those matrices, right? So like generating embeddings where you need to turn a string of text into numbers. And then those numbers should represent the underlying ideas that are represented in the text, the tone of the text, things like that. So as far as, how does the development of the models that go to translate that, there could be some people who are doing some really cool things with it. If they are working on the models themselves. They're not external people who say, like, I'm a prompt engineer on their LinkedIn, but, they...
So you need a computer science degree, not an English degree, to be a prompt engineer, is what you're saying? Or like you couldn't have a linguistics major with an English minor to be a prompt engineer. You would have to have some coding background.
Yeah, again, it depends on how people are using it. I'm skeptical about the title prompt engineer, but there could be something that I don't know. I don't want to.
It could be like a QA person for a video game company that just plays the game and tries to break it. Is what
Shane's
I'm reading.
Shane's little
it as
dream job.
Yeah.
No, that job sucks.
So one thing that I've been thinking about, Matt, is I think ChatGPT 4 goes up into the present, but for a while there was this warning on the website that said, we only have information up until I think it was like September of 2021. So like mechanically,
that's still the case.
It's still the case. So what is that like? Why? Like, is it because it's going to take so much computing power to get up to date? Like, why don't we have up to date information? And what's it going to take to get there?
So the way that these models work, especially like a GPT model, they're a little bit different from how a human will learn stuff, right? So these models they do one really large batch training of the data, and then they learn all of their underlying relationships and everything from there. And those are really, really expensive. It takes a huge amount of computation, and some of these train for months before they're actually satisfied with the results and they have learned the relationships in the text that they're looking for. So a big chunk of that, I believe, was they just did one training of the model, and then they probably did do some reinforcement learning and the layer of that on top of it. But it didn't make sense for them to be doing continual retrains. So the actual underlying data wasn't there.
Got it.
But in that training phase, what they're doing is they're just looking for those patterns and those relationships, right? They're not actually reading stuff and synthesizing it, right? So it learns those patterns in a way that when you paste in new information, it can take new information. My understanding is that what they're doing, or what they're planning to do, is they're having it so when you ask it a question that requires external data, it can now go read data from that website, or it can do a Google search and it can take that back. And instead of additional training, it just gives it basically an extension of your prompt to run the model on.
Got it. Yeah, because ChatGPT at this point doesn't know that that Russia invaded the Ukraine. It doesn't know that Trump was indicted. It doesn't know that you can buy Glossier products in Sephora. Like, it doesn't have that information unless you tell it or you send it to a website. So I always found that super fascinating. And like for our purposes in our industry, we'd like to think about like what happened in the stock market last year. Can we provide some analysis? It's like, well, we can't do that because we don't have the data yet from ChatGPT. So interesting limitation.
Yeah. And, at the same time, I could imagine part of that is them trying to save some money while they're doing this initial like testing to sort of fine tune it, right? Because in the same way, they don't want you copying and pasting in an entire book, because it's just going to take so much money to crunch through all of that, convert it into numbers, generate some response. I would assume there was an element of not a technical hurdle, but not wanting it open to the internet just for that purpose.
For sure. And we're in the age of $20 a month for ChatGPT. This is like when Uber was like $2 a ride, just so there could get a massive of user data to start, perfecting the algorithm. So I imagine we're still in that honeymoon phase, so to speak, for early adopters. Basically, like, we get a super discounted price because we're giving it all of our data and we're teaching it more about the way humans think and what humans want to know.
Yeah. Love to burn VC money. AJ, your questions around resource intensiveness and it being open to the outside world really has me wondering about when the tool is most resource intensive. Like, I know that when they were originally developing ChatGPT 3 and 3.5, that they had thousands of GPUs that they were using to train the tool, Matt. just to get some extra processing power. And it makes me wonder, like, is the tool most resource intensive only when it's in the oven or when it's on the table? Like when we're using it or when it's being developed. And I know that it can it can now use APIs. It now has an API, and some other tools can now access ChatGPT. And I was just curious of like, is that resource intensive for the company? And you might not know the answers to the specific about ChatGPT, but I'm also curious, like, if you're excited about the APIs and like if you could talk to us about how they work. Like, I know that Wolfram Alpha now has a ChatGPT API. Like, what does that mean for you and I?
Mm-hmm. Yeah. So let me unpack that one
two
step
questions,
at a time.
yeah.
So, as far as the resource intensiveness, it is going to be intensive to do the generative step as well. So there are a lot of models where, it can be really expensive or take a lot of computing resources to train them. But then at the inference step where you're actually making predictions and using it, it's pretty lightweight. That is not the case for language models, because with language models, there's still a lot of computation that needs to happen to turn your prompt into numbers and then to pass that through this whole model and, fetch a bunch of matrices, multiply them together, and then turn that back into text, right? So without a lot of investment and, getting free hosting from giant tech companies, ChatGPT would not be possible in its current state. But that's not my understanding, at least. I don't know this for sure, right? I have never trained a large language model myself. But my understanding is that it probably was a lot more expensive to do that initial training, right? Because it's just around the clock. Yeah, you got your like hardware running at full throttle for months.
Cool. And it also makes me think about there's not, ChatGPT isn't the only model. So how should we be thinking about some of the other entrants and some of the original and some of the newer ones coming in, like the efficacy and the efficiency of various models? Do you know some of the KPIs? I've seen some papers about LLMs, and I've seen like some charts that I don't know how to interpret. So I was hoping you might be able to help us with the KPIs that we should be thinking about. Is it like the speed of the response? Is it the number of neural activations? I don't know what to help us out here.
Well, and this one is interesting, right? Because in some ways we're breaking new trail and the answers aren't clear for that, right? So of course it can capture a lot more nuance the more data you capture, and the bigger your embeddings are, you can hold more information to be used by the models, but that doesn't always equate to them being more accurate, right? So, for example, in one of my previous jobs, we were working with BERT, which is another transformer model, and we were taking the data out of that. But one of the biggest challenges there was we actually needed to localize it. It had been trained on too big of a data set and all of this text, Wikipedia, the internet, all of this. So if we're doing something like, in this case, we were working with food data, so with recipes and food products, nutrition, stuff like that. So we didn't care that it had been trained on the seismology of Mars and K-pop or whatever other things made it into Mars, right? So we were actually localizing it at that point. So we were working to simplify, actually remove data from it. And unlike, if you're trying to predict the weather, right? You have a very clear way of assessing, was this good or was this not good, right? If you say, hey, it's going to be 50 degrees and then it's 40 degrees, you know exactly how wrong your model was. Whereas something like a conversation or just generating text, or especially with some of these other ones where we're generating images, we're generating art, audio, stuff like that, that's a lot harder to assess because you don't have those clear metrics. And ChatGPT or OpenAI, in their APIs that you were talking about, they have different versions of it, right? So I've played around with them a little bit. They have 3 or 4 different versions of every model, and they come at at different sizes. So they have the one that's supposed to be really fast because it has a little bit less information involved, included in the embedding. And then they have other ones that are supposed to be better, more accurate, and they're huge, but they're going to be slower because multiplying all those numbers together is going to take a lot more computation. So I realize I didn't give you an exact answer there. I'm sure that researchers have good ways of how they're evaluating these large language models, but yeah, I'm not sure if there is a clear answer to what our best metrics are going to be. That said, part of what they're doing to get around that is why when you use ChatGPT now, they're making it free, not because like for the main purpose of, testing and improving it. So you say, was this good? Was this not good?
I mean, what I heard is that it's similar to people. Like,
Yeah.
they're going to have different resumes. They're going to
Right.
have different abilities. Some of them are going to be faster. Some are going to be slower. Some are specific. Some are broad. Yeah.
Some are going to have a
Very
good sense of
interesting.
humor. Some are going to have a bad
Yeah.
sense of humor.
Yeah. And they could potentially talk to each other via APIs.
Yeah, exactly. And then
Yeah.
kill us all. What are you most excited about in terms of the like real life implications of having AI integrated into systems? Like for us, it's like, oh, we can play with it. We can like summarize copy. Like, this is cool. Like, how is this going to change our day-to-day lives? Like, as someone who understands this stuff on a much deeper level than I do, like 2, 3, 5 years from now, like, what do you think is going to be the biggest, most exciting development that based on what you've seen so far?
That's another tough one to predict. I have all sorts of theories about what I think is going to happen. But I would say probably the thing that I'm the most excited about, also maybe a little bit scared of, but right now, all of our models are very specialized in what they do. So, if you build a model to play chess, no human will ever stand a chance. Like, no human can beat a model at chess, right? And it's like that with most things, right? If you build machine learning to predict the weather, no human's going to hold a finger up to the wind and be able to guess better than some really complex model. But if you build one model, a human will be better at it at almost everything except for the one thing it specializes in. Some of what we're starting to get at now is backing out, and not to, jump into AGI too early, but we're starting to back out a little bit and broaden the scope of what models can do, or the ability to, orchestrate some of these models. So you have one model that works as a controller and knows when to use what other model. That's kind of an abstract thing that I'm really interested to see, how that impacts all of us. At the same time, there's a lot of in development of software and in research and building models, there's a lot of tedious, annoying work that, is necessary to do, but it's not that fun, right? We're starting to see it's possible to automate some of that. We're not very good at it yet, right? Like Copilot or ChatGPT can't really replace our code yet, right? But it is starting to be able to write some of our tests. And it can give you a good starting point in certain languages and on certain simple tasks. I'm excited to see that get better. Basically, I'm
Cool.
excited to give all the boring parts of my work to ChatGPT and focus on, the things I'm good at and actually enjoy doing.
Yeah, for sure. I think the implications across industries, I just feel like we're such the tip of the iceberg. Like, we just don't even know where it's going to go. And I can't even think about the exciting implications. We are at time. Any final parting thoughts about the future of AI?
Yeah, it's gonna be interesting. And, finding out who, what I hope that I see is that people are able to get successful in AI. So companies are successful in AI because of innovation and not just because of money, right? I mean, currently in tech, you have 4 companies that control everything. And I was a little bit let down with some of the investment that happened into OpenAI from Microsoft, right? But I still think that companies who can't outspend these giant companies can out innovate. And I think we're really like the beginning of the internet days, right? Where there's a lot of opportunity and some really smart, creative people are going to be able to, come up with something really impactful and innovate.
Fuck yeah, let's innovate. Well, thank
Yeah.
you so much, Matt. Always love your perspective on things that are not our expertise, and always happy to have you on the Liquidity Event. Thanks so much for listening, everyone. You can email us your financial problems at liquidityevent@brooklynfi.com. Leave us a voicemail at memo.fm/liquidityevent. And of course, you can find the show notes, and don't forget to fill out our survey at brooklynfi.com/episode 90. We will see you next week. Thanks for watching.